Today we will discuss our new test series. This test includes the test of aggregate. The title of this test is Los Angeles Abrasion Test. Los Angeles test is a widely used method to measure the resistance of aggregates such as stone, gravel, or sand to abrasion and wear. Abrasion is the process of wear and tear. We called Abrasion is the process of wear and tear, which is generally caused by the friction, impact, or rubbing against a surface, resulting in the removal of material from the surface. Abrasion can occur through various mechanisms, which includes the friction, impact, erosion, and grinding. Friction generally includes the sliding or rubbing against a surface, causing wear and tear, whereas the impact, which is situated as the repeated blows or impacts leading to material removal. We have seen many times that this impact can be demonstrated by the continuous removal of material from the asphalt in form of aggregate when a vehicle or many vehicles roll through it, or we can say roll on it. Number 3, we have erosion, which is generally as the wear which is caused by the flow of fluids, gases, or solids. And number 4, at the end, we have the grinding, which is the material removal through grinding or crushing actions. Here we have the title, an experiment to determine Los Angeles abrasion value of aggregate and to ascertain its conforming to NHA specifications. We have National Highway Authority specifications here. We have the apparatus here. This is our apparatus, which includes the access cover here, the access cover. The second term is the revolution counter, and the third term is our cylinder, and the fourth one we have our steel balls. These steel balls are usually of 47 millimeter in diameter. Coming towards the theoretical background, Los Angeles test measures hardness of aggregate. Hardness refers to its resistance to wear, scratching, and abrasion. Its important property in field of construction. It's an important property in the field of construction as it affects their durability and performance in various applications. Hardness of aggregate is generally classified into different categories, including the soft aggregates, the medium aggregates, the hard aggregates, and the very hard aggregate. The soft aggregate includes the limestone, sandstone, and shale, whereas the medium hard aggregate includes the granite, basalt, and dolomite. Next one, we have the hard aggregate, which includes the feldspar, which is an igneous rock, the quartzite, and mica. Number 4, we have the very hard aggregate, which includes the topaz and diamond. Hardness of aggregate affects its durability, abrasion resistance, crushability, workability, and strength. In construction, we have harder aggregates, and we generally prefer these harder aggregates due to the following reasons. Due to the following aspects, where we have the high traffic roads, airport runways, high strength concrete, and decorative applications, whereas we prefer the softer aggregates in the places of low traffic roads, building construction, landscaping, and drainage applications. Los Angeles test assesses hardness of aggregates against attrition and abrasion. We have discussed these both terms. The aggregate used in surface course of the highway pavements are subjected to wearing due to movement of traffic. When vehicles move on the road, the soil particle present between the pneumatic tires and road surface cause abrasion of aggregates. The steel rimmed wheels of animal driven vehicles also cause considerable abrasion of the road surface. Aggregate used in other courses of road should also be hard enough to qualify the designated lab test. Coming towards the scope of the test is for the resistance to degradation of coarse aggregate by abrasion and impact in the Los Angeles machine, which we have discussed earlier, and we also have discussed its parts. Two different test methods are used, one for small size and one for the large size coarse aggregates. We have references and specification in subsequent slides. We have standards as ASTM C131 for the small size aggregates and ASTM C535 for large size aggregates. This test is a measure of degradation of mineral aggregates of standard grading resulting from a combination of actions including abrasion or attrition, impact and grinding in a rotating steel drum containing a specified number of steel spheres. Here we have the chart which shows the sample grading and abrasive charge. Here we have the sieve size passing 37.5 millimeter. Here is the scale of inch, here is millimeter, and these are the grades A, B, C, D. These are the sample amount which is generally situated as in grams. These are the sample choices. Then we have here the mass of charge, and these denotes the number of sphere we used in while categorizing the aggregates in these grades. We have A grade, and we use number of spheres we use are 12. When we have B grade, we use 11 spheres. When we have C, we use 8 spheres, and when we have D, we use 6 spheres of 47 millimeter in diameter. Coming towards the procedure, the test sample should be thoroughly washed and oven dried and is taken according to gradation in tables. Number 2, we have the test sample and the abrasive charges which shall be placed in Los Angeles abrasion machine, and the machine is rotated at a speed of 30 to 33 rpm revolution per minute for 500 revolutions for test method ASTO T96, which is ASTM 131, and 1000 revolutions for test method ASTM C 535. Moving further, we have point number 3. After the prescribed number of revolutions, the material shall be discharged carefully from the machine and shall be sieved on 1.7 millimeter, which is generally number 12 sieve. Then point number 4, we have to wash the material coarser than sieve number 12, dry to constant mass at 110 degree plus minus 5 degree centigrade, and record mass to the nearest 1 gram. Here is the most important part of our test, the observations and calculations. Calculate the loss difference between the original mass and the final mass of the test sample as a percentage of the original mass of the sample. First, we will have the total mass of the sample before test. Here we will write the total mass. Then we have the mass of sample retained sieve number 12. Retained means it remain or it restrained back on the sieve number 12. It don't passes the sieve number 12. Here we have that mass. Then after it we have the difference, which is which known as abrasion value of aggregate, which is the difference of these two terms divided by the first term, and we will have the abrasion percentage. Now we have NHA specifications, which are discussion on results. Item 201, granular sub-base. The coarse aggregate material retained on sieve number 4 shall have a percentage of wear by Los Angeles abrasion test AASHTO T96 of not more than 50%. Number 2, we have specification item 202, aggregate base course. The coarse aggregate material retained on sieve number 4 shall have a percentage of wear by Los Angeles abrasion test AASHTO T96 of not more than 40%. NHA generally holds or generally uses this standard AASHTO T96. We have the number 3 specification, item 305, asphaltic concrete wearing course plant mix, coarse and fine aggregates, percent wear by Los Angeles abrasion test shall not be more than 30%. We have a note here that there are other specification of other types of bases and sub bases also mentioned in NHA specification, but above are mostly commonly used. Thanks for watching.